In the last section, we saw the 5-number summary as a way to describe the variability of a distribution. And now we'll look at another description of variability using the mean and standard deviation. And the standard deviation measures variability by looking at how far the observations are from their mean. So this is another measure of variability, but we're going to use it in more specific cases than a 5-number summary. So 5-number summary is good for any distribution, but using the mean and standard deviation is only going to be good for certain distributions. So first, let's define what I mean by deviation. So the deviation of an observation xk is its distance from the mean of the set of observations x bar. So that's just the difference. Xk minus x bar is the deviation. So let's look at an example of that. This table shows the rate of return of investment in a fund that invests in intermediate term fixed income securities for a recent 10-year period. So we're looking at the period from the year 2000 to 2009, and this chart shows the return in percentages. So the mean return for these observations is 7.21%. Now let's calculate the deviations. So I've copied my chart again here, and to find the deviation, I'm just going to take my observation. So my first observation is 11.56 and subtract the mean of the observations, which I said was 7.21. So for this first one, the deviation is going to be 4.35. And that's just subtracting the mean from the observation. So I can go ahead and do that for each of these and fill in this chart. So this is going to be 8.99 minus 7.21, which is equal to 1.78. Then I have 9.69 minus 7.21, which is equal to 2.48. And then I have 5.07 minus 7.21 is equal to negative 2.14. 4.65 minus 7.21 is equal to negative 2.56. 2.41 minus 7.21 is equal to negative 4.8. 3.51 minus 7.21 is equal to negative 3.7. 8.57 minus 7.21 is equal to 1.36. 4.32 minus 7.21 is equal to negative 2.89. And finally, 13.33 minus 7.21 is equal to 6.12. So those are all of my deviations. So let's look at what that means exactly. So here I've copied my chart, and this is a picture. I've got a dot plot of all of my observations, and I've marked my mean here at 7.21, and the deviation is the distance between the observation and the mean. If the observation is smaller than the mean, then we're going to have a negative deviation, and if the observation is larger than the mean, then we'll have a positive deviation. So we've looked at deviations. Now let's look at what the standard deviation is. And this is kind of the average amount that the observed data values deviate from their mean. So it's kind of like a mean of the deviations, but it's a little bit different. We're going to take the square root of the sums of the squared deviations divided by the number of observations minus 1. So that gives us this formula down here. So if we have n observations, and I label them x1 up to xn, then the standard deviation is given by this formula, where x bar is the mean. I'm subtracting, so I'm finding the deviation for each observation and squaring it. Then I'm adding them all together and dividing by the number of observations minus 1 and taking the square root of this whole thing. So that's a little bit complicated. Here are a couple of helpful hints for when you're calculating a standard deviation to help you check. The standard deviation is never less than the positive difference between the mean and the median, and it's usually close to a quarter of the range. So let's go back and look at our example again. So we said that the mean return for these observations is 7.21. Let's look at the median so we can find the difference between the mean and the median, and then we'll also look at the range and find what a quarter of the range is, so that when we calculate the standard deviation we'll have something to check with. So here I've arranged all the observations in increasing order from my smallest to my largest. In the median, I've got 10 observations, so I'm going to take the middle 2 observations and add them together and divide by 2 to find my median. So m is equal to 5.07 plus 8.57 divided by 2, which is 6.82. So that's my median. The positive difference, I'm going to take the larger of the mean and the median, so the mean is larger, 7.21, and subtract the median, 6.82, and that will give me a difference of 0.39. So that's the difference between my mean and the median. Now let's look at the range. So the range is my max, which is 13.33, minus my minimum, which is 2.41. So I've got a range of 10.92, and a quarter of that would be 10.92 divided by 4 is equal to 2.73. So from what we said before, the standard deviation has to be bigger than the positive difference, which is 0.39, and we expect it to be close to a quarter of the range, which is 2.73. So now let's go ahead and calculate the standard deviation. First, I've added another column to my chart here, and I want to calculate the squared deviations of these observations. So I'm just going to square each of these numbers I found here. So 4.35 squared is equal to about 18.9. I'm rounding to one decimal place here. Then 1.78 squared is equal to about 3.2. 2.48 squared is equal to about 6.2. Negative 2.14 squared is equal to about 4.6. Negative 2.56 squared is equal to about 6.6. Negative 4.8 squared is equal to about 23.0. Negative 3.7 squared is equal to about 13.7. 1.36 squared is equal to about 1.8. Negative 2.89 squared is equal to about 8.4. And 6.12 squared is equal to about 37.5. So I've filled in all of my squared deviations now. Now I just need to plug everything into my formula for standard deviation. So I've rewritten my squared deviations here in this chart. And to find the standard deviation, I'm going to add up all of my squared deviations, divide by my number of observations minus 1. I had 10 observations, so minus 1 is 9. And then take the square root of this whole thing. And that will give me 3.7%. So let's look at what we said before. We said the standard deviation has to be bigger than 0.39, and it certainly is. And we expect it to be close to 2.73. So we're 1 away. We've got 3.7, so I'd say that is pretty close. Some things to observe here. The standard deviation is equal to 0 only when there is no variability, or that is when all of the observations have the same value, when all of the observations are exactly the same. Otherwise, the standard deviation is going to be greater than 0. The standard deviation has the same units of measure as the original observations. So here we were looking at rate of return in percentages. So the standard deviation is also in return in percent. The use of squared deviations makes the standard deviation even more sensitive than the mean to a few extreme observations. So distributions with outliers and strongly skewed distributions have large standard deviations. So since those things have so much of an effect on the standard deviation and the mean, the 5-number summary is usually better for describing a skewed distribution or a distribution with outliers, and we're just going to use the mean and standard deviation for reasonably symmetric distributions that don't have any outliers. So that's the end of this section. Things you should know. You should be able to calculate the standard deviation of a data set, and then check if your calculation is reasonable by using the difference between the mean and the median and a quarter of the range. You should be able to tell if standard deviation is a good measure of variability, and this will be true if the distribution is reasonably symmetric and doesn't have any outliers.